Hello everyone. Let's see how many of you has joined. Sumit Sukla. Hello Sumit, how are you? Good evening Bishal. How are you Bishal? So we have Vishal with us, we have Sumit with us. Let me just wait a few more minutes to others to join. Good evening all. Welcome to Unacademy. Our today's topic will be real world mathematics. In this we will be discussing about the topic probability and how this is affect our real world mathematics. So let me just clear out one concept here, right? That we think, we presume that mathematics first came and then we started applying those in real world, right? Even in books we call it applied mathematics or application of mathematics, right? But actually it's not like that. Even the science is also not like that. Everything that we know, that we are doing, that we are discovering is already there, present in the nature, right? We are just actually rediscovering it. We are reinventing it. We are trying to find out how it works, right? So mathematics is the language of science. So we are just learning this language to understand the science, and science is what the nature is. So actually mathematics is the way to learn the nature. That is what you will be learning when you go for the applied mathematics. We'll be learning this only, that wow, the mathematics can be helpful for science to understand the real world problems and the nature, especially the nature, because every invention, everything is inspired by nature. Then we got the idea from nature and then we are applying that to the other subject, other our in for our benefit. We are applying them, right? Hi Shamit. Chalo, so we are going to start with this topic very soon. So in this topic, we are talking about the concept called probability. So probability is something that we discuss every day, right? In our everyday, we use the words like may, probably, doubt, chances, unlikely, right? These are the words that we use every day, isn't it? So every day we come across such statements like it may rain today. Probably Arvind will top the board exam this year, though Arvind is one of my favorite students. I doubt she will pass the test. It's unlikely that India will win the Cricket World Cup. Chances are high that the price of the petrol will go up. So these are something which are very, very common topic or very common word that I use every day, right? So so these statements gives or indicates some uncertainty, right? So for example, it may rain today, it may rain or may not rain today. We are just predicting rain today based on our past experience when it rained under such similar conditions. Similarly, the prediction are made on the cases listed on the second and fourth also, that probably Arvind will top this year, and it's also predicting that the chances are high that petrol prices will go up, right? So everything that we are doing here is a kind of it's a kind of prediction that we are making, right? Isn't it? So these are the prediction that we are making, and that gives us the concept of probability. It was developed so many years ago. First, it's not like that. There are a lot of different mathematicians worked on this, like the modern theory of probability, the Italian mathematician Jerome Cardin, French mathematician Medici Pascal, then Swiss mathematician, Russian mathematicians, they started also the theory of probability. The Laplace wrote, "It is remarkable that in a science which begins with the consideration of game of chance should be elevated to the rank of most important subject of human knowledge." Probably that's why the probability is used extensively in the field of physical science, commerce, biological science, medical science, weather forecasting, and even to predict the consequences of the pandemic that we are having now. Statistics and probability, these are two things which can predict how this pandemic can go based on our past experience and the various models, right? Two things are actually helping us to predict what's going to happen in this pandemic situation. One thing is the probability and the statistics, and the second thing, AI technology, right? So that is why this even in the current situation, the probability is one of the most important topic that we are going to have. Remember, I just want to talk about Unacademy a little for the students who are just joining the classes. Unacademy is India's largest learning platform. Live session with the best educators, live practice question with the educators, weekly quizzes, and live doubt clearing classes always happen in Unacademy Plus platform. Okay, so if you go with the code ST18, you will get 10% of discount on Plus subscription. So don't forget to go for ST18 code. We are offering plus 9 to plus 12 the board level classes. Okay, so in the pandemic situation, this is the best way to learn from the safety of your home. What we are getting, learn live from the comfort of your home, unlimited access to the course if you're going for the plus subscription, top educators of India in one platform, extensive coverage of the syllabus, regular doubt clearing classes, one after every 3 class, live test series, study material in the PDF format, answer writing sessions, mentorship and guidance. Everything is available in the Unacademy Plus platform with 10% discount with the code ST18. What you have to do, you just need to go to the Unacademy. You have to choose the goal, the CBSE class 9, then you have to select for how many months you are going for the subscription, and then you have to go for the payment. Then in the payment section you will have the option to use a referral code. Use the code ST18 and you will get an instant discount of 10%. By the way, this is my introduction. I'm having in 7 years of experience, more than 10,000 hours of online classes. I covered the foreign boards also. I'm a master teacher. So if you go for the 6-month subscription or 10-month subscription, then if 12-month subscription, in that case the pricing will be 1,042 rupees per month. But in case you have copied the code ST18 and you are going for the 10% discount, then you will be led to pay 938 per month, 938 rupees per month for all the subjects for the entire year and for unlimited courses. Okay, so don't forget to go for the the code ST18. Okay, Vishal says the statistics is complete. No, statistics is not completed by me, but I believe the other educators have already completed the statistics. We are going with the classes now. So this is the history and the origin of the topic, the probability. It's one of the most interesting topic it actually, its origin, how this topic started, it's one of the most interesting story behind it we have. So origin of the subject can be traced in the correspondence between two French mathematicians, the Pascal and Fermat. In 1654, a French nobleman and a gambler, uh, Carlis Meret, asked Pascal to solve a certain problem. The Pascal solved these problems in collaboration with the Fermat. That is the subject. Then that concept becomes the subject called probability. It was actually developed for the gamblers, so that they can predict, based on the previous experience, we can predict this is going to be the answer for this kind of concept, or this is the way they can predict this is going to be the most probable number I should gamble for. Okay, then de Moivre's, one of the most important and renowned mathematician, doctrine of chances, written his book. Laplace published analytic theory of probability. Then over the centuries we have a lot of new mathematicians, mainly from Russia. They are also extensively used the various field of probability. They explored it, and now the modern theory of probability has what we have. Yeah, but this is a relatively a new concept, so there are a lot of chances of doing a lot of things using this concept. Yes, Bhavesh, it is very easy chapter, but we are just learning the basic of it. Okay, if you look at the syllabus of like in Indian syllabus we are not having all this, but even in the foreign syllabus, if you are looking at the 11th 12th level statistics, is quite hard because it's a very interesting chapter. It has a lot of things to do with it. Like this particular topic is includes the set concept, it includes the statistical concept, it includes the graphical concept. So a lot of things are included in the topic called probability. Okay, so anyway, we are going to first learn the probability. The way will be learning the probability, that is going to help you in 11th, when we'll be learn 11th and 12th. Okay, because generally what happens, we go for the formula and we solve the problem. It's not like that. Probability is not such a simple thing. We need to learn the each and every term properly. Okay, then only it will be helpful for us to get the core concept of it. So first of all, I will be going with the topic called experiment. The terms experiment. Okay, so what is experiment? An operation which can produce some well defined outcomes is called an experiment. So the outcomes that we will be having need to be well defined. The definition should be proper and perfect. Okay, each outcome is known as an event. Okay, so experiment, an operation which can produce some of the well defined outcomes, is called an experiment, and each outcome called an event. Clear? Sir, you are from which country? Sumit Sukla, I am very much Indian. Okay, anyway, so random experiment. So what is called random experiment? Random experiment, an experiment in which all possible outcomes are known and the exact outcome cannot be predicted in advance, is known as random experiment. So experiment and random experiment is the point where they are separate. So all the experiments are not random experiment. For example, I am throwing a coin. Okay, so it is a random experiment because you know all possible outcomes. I already know that my outcomes are head or tail, right? But I can't predict what is going to be the outcome. Like I can't say it is going to be head always, it is going to be tail always. You can just guess, but you can't predict, right? You can definitely say this is going to be the perfect outcome when you throw a coin. So that is something called random experiment. But what is not a random experiment? When all possible outcomes are not known. That is not a random experiment, but it is an experiment. But the outcomes are well defined. Okay. Trial. What is trial? By a trial, we mean performing a random experiment. So if I am doing a trial, it means I am performing a random experiment. So throwing a coin is a trial, throwing a die is a trial, throwing pulling a card from 52 pack of cards is a trial. So these are examples of trials. Okay, fine. So this is the experiment, random experiment, and the trial. Okay, so anyone having any doubt, just let me know quickly. So we will be now discussing about the concept called trial. Okay, so a trial is an action which results in one or several outcomes. A trial is an action which results in one or several outcomes. For example, if we toss a coin, it is a trial. The possible outcomes are head or tail. If we toss 10 coins, then those 10 those are 10 trials. Okay, so throwing one coin is a trial. If I am performing the same thing again and again, that means I am doing the trial again and again, but outcomes will not change. Outcome will be either head or tail. Okay, if I throw a die, that is a trial. Possible outcomes are 1, 2, 3, 4, 5, 6. But if we throw the die 15 times, all of the 15s will be a trial. So we perform 15 trials. Okay. Third point is if we toss two coins simultaneously, it is a trial. Possible outcomes are 2 head, 1 head, or no head. Or possible outcomes may be taken as 2 tail, 1 tail, no tail. Or possible outcomes also can be taken as 2 head, 1 tail, or 2 tails. If we toss 2 coins simultaneously for 20 times, then those are 20 trials. Okay, those are 20 trials because we are performing a random experiment 20 times. That means we are performing 20 trials. Clear? Clear? So a trial is an action which results one or several outcomes. Each outcome is known as an event. The events need to be well defined. Then we'll be having, I will call them as event. Now, experiment, an action which results in some well defined outcomes is called an experiment. Okay. For example, tossing a coin once is an experiment. Tossing a coin 10 times is an experiment. Throwing a die once is an experiment. Throwing a die 15 times is an experiment. All these are experiments. Okay. Events. Collection of some outcomes of an experiment is called the event of the experiment. Okay. So events means the collection of some outcomes of an experiment is called the event of the experiment. For example, when a die is thrown, 6 outcomes number 1, 2, 3, 4, 5, 6, then getting a 6 is an event. Getting an even number is an event. Getting an odd number is an event. Getting a prime number is an event. Getting a number more than 6 is an event. Getting a number less than 1 is an event. Maybe those events are not possible, but these are also an event, like getting a number more than 6 when I throw a die. That's not possible, but that is an event. Birenchi Narayan Misra. Hi Birenchi. How are you? So this is an event, right? Now we will be talking about occurrence of the event, like when we can say an event has occurred. Okay, that's called occurrence of an event. So when we can say that event has occurred. So when the outcome of an experiment satisfy the condition mentioned in the event, we say that event has occurred or the event has happened. Okay. For example, in an experiment of tossing a coin, the event E may be getting a head. So we are considering getting a head is an event. Now, if the coin comes up with a head, we say that event E has occurred. Otherwise, if the coins comes up with tail, then we say event E didn't happen or has not occurred. Okay. Now, in an experiment of tossing a pair of coins simultaneously, an event E may be getting two heads if the pair of coins comes up with two heads. Okay. We say that the event E has occurred, otherwise we say event E has not occurred. Okay. In the experiment of throwing a die, an event E may be getting an even number. If the die comes up with any number 1, 2, 5, 6, we say the event E has occurred. Otherwise we say, like if it comes out with 1, 3, 5, the event E doesn't happen or didn't occur. For convenience, event E, we mean the event E has occurred. Like if I say the event E, it means that event E has occurred. Okay. So that is what the concept of occurrence of an event. Clear? Any doubt? Anyone having? Now the formula. This is an empirical probability formula or empirical formula of probability. It says suppose we perform an experiment, let n be the total number of trials, that empirical probability happening of an event E is defined by number of trials in which the event happened by total number of trials. Okay, Sumit Sukla has a question, what we mean by the event, right? Event means a collection of some outcomes of an experiment is called an event. Say you are throwing a coin. Okay, so if you are throwing a coin, you will be having how many outcomes? I will be having 1, 2, 3, 4, 5, 6, right? So these are what? All outcomes. This is known as sample set or sample space. Sample space is the collection of all outcomes. Okay, so this is my sample space. Now I am defining an event which is nothing but all even numbers. So this is an event. So even numbers are 2, 4, 6, right? Now if you throw a die, if you get 2, that means you can say let's name this event as E1. So you can say E1 happened, E1 occurred. You throw a die, you get 5. You can say E1 didn't happen or has not occurred. You throw a die, you got 6. You say E1 happened, E1 occurred. Okay, so this is what is called event. Okay, so any one of these 3 outcomes, if I get, we can say the event E happened. It's not like that all 3 should happen together. It's like that any one of the 3 happen together. Hi Harshavardhan Singh, welcome to the classes. Empirical probability. Okay, so what is empirical probability? Empirical probability, suppose an experiment, suppose we perform an experiment, n be the total number of trials, the empirical probability happening of event E will be defined by number of trials in which the event happened by total number of trials. This is the basic probability. Like there is to be 2 kind of probability, empirical probability formula or theoretical probability formula in this one. Right? Theoretically we say this is going to be the probability of the event, and one other is experimental probability. Okay, so I will with an example I will later explain you that what is experimental probability and what is empirical probability. We have both of them. Event tells what is the outcome. Yes, event tells what is the outcome. What outcome we got. Okay. Now, some of the operations and their outcomes. Now, I have taken some of the basic operations and their outcomes because these are the things that we are going to try again and again as our events or as our experiments. Okay. So here we have the first of all tossing a coin. So when I toss a coin, there is two outcomes, head or tail. Tossing two coins, there will be four outcomes, two head or one head or zero head, two tails, one tail or zero tail, or specifically we will be having head head, head tail, tail head and tail tail. Okay, now just think like how many different ways I can look at an outcome, right, or my event. So this is like two head, in these two cases one head, and in these two cases no head, right? This is two head, this is one head, no head, zero head. So that means these outcomes are classified based on the number of heads we are having. Similarly, we can classify them based on the number of tails we are having. We can classify them based on number of head tail we are having. Two head, one tail and two tail. Okay. So these are the different ways of looking at an experiment. So we are going with the new next thing, throwing a die. So when I throw a die, die is the plural form of dice. So you might be thinking that why we are saying die not dice. So because it is a plural form of dice. So a die is a cubical solid having 6 faces, right? I will try to draw a die here if I can. So it is in cuboid or cube having 6 faces, right? So this is an die. So it's like 1, then 2, then 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So such a way the dots used to be given, right? Anyway, in 3D it's quite hard to write it down. So this is a die. There are 6 outcomes, 1, 2, 3, 4, 5. Choosing the various types of number of number out of the given numbers. So suppose continuing numbers 1 to 10 given. So there can be prime numbers, there can be even numbers, there can be odd numbers, there can be multiple of 2, multiple of 4, multiple of 6. Such a way there will be different ways we can classify our events. So I'm going with the new question. It says that a coin is tossed 600 times. Okay, a coin is tossed 600 times. Heads we are getting 342 and tails is 258. We are getting head 342 times and we are getting tail 258 times. The question is, if a coin is tossed at random, what is the probability of getting a head or getting a tail? Okay, so here we are considering getting a head is the event 1 and getting a tail is event 2. Okay, so we are first naming the event. So now probability of event 1 will be number of total outcomes. So what is the total outcomes? How many times we toss the coins? It is 600 times, right? How many times we got head? 342, right? So this is going to be your answer, 342 divided by 6. Okay, so if I cancel out, I get 100. If I cancel out, I get 6 5s are 30, 6 7s are 50, 42. So 57 by 100 is the probability of getting head, or if I convert it into decimal, then it is 0.57. I can convert it into percentage, it is 57%. So that means what we mean by this probability of event 1 as 57 by 100, that means if I throw it 100 times, there is a probability 57 times I will be getting head, and 43 times I'll be getting tail. Okay, that's what it means by the 57 by 100, the probability of event E means. So as we see that the probability of getting head is higher, so whenever a coin is thrown, it's more probable that it will go with the head, not with the tail. But it's something that is completely something we are predicting. It doesn't mean that it will happen. Okay, so this is something called experimental probability, because we have done an experiment, that is we have done this thing 600 times, we got it 342 times head and 258 times tail, and based on that we are saying that the probability of getting head 342 by 600, that's something called experimental probability. Okay, so what will be the probability of getting tail? E2 will be the number of times the event happened, 600, and number of times we got tail is 258, right? So if I simplify, it will be 43 by 100, right, or 0.43 or 43%, right? So this is what it is. Clear? Now, yes, Sumit, correct. Now remember, there is something we should know, that is a probability of an event cannot be more than 1 or cannot be less than 0. Okay, probability of event cannot be more than 1 or less than 0. So we can write 0 less than equals to probability of an event. It can be anything less than equals to 1. I'm not just talking about this one, I'm talking about at random. Any number, if I any event if I have, its probability will not go more than 1 or it cannot be less than 0. That's called the range of the probability. Okay, when the probability is 0, okay, when the probability is 0, this is called an impossible event. Impossible event. So in case of impossible event, the probability is 0. For example, if you are throwing a die, and the question is, what is the probability of getting, if you are throwing a die, what is the probability of getting a number more than 6? So if you throw a die, a standard die, then you cannot have a number more than 6, right? So probability of such event will be 0, because favorable outcome will be 0. The numerator will be 0. So that is something we call impossible event, right? And probability of its event is 1. That means it is called an sure event or certain event. Okay. Impossible event and sure event. Probability of event is 1 means what? The probability of say a number less than 6. When you throw a die, a number less than 6 or less than equals to 6. Okay, so all the numbers, if I throw a die, will be less than equals to 6. So here the probability is 1. So that is an sure event. Okay. So we are going with the next question. It says that two coins are tossed simultaneously for 400 times and we got head 180 times, two head 180 times, one head 148 times, no head 72 times. If two coins are tossed at random, what is the probability of getting 2 head, 1 head, 0 head? What is the probability? Sumit, probability cannot be more than 1. No, it cannot be more than 1. I will show you that why it cannot be more than 1 after this question, okay? Or I may use this question also to answer it. So probability cannot be more than 1 for any means. Two coins are tossed simultaneously 400 times and we got two heads 180 times and one head 148 times and no head 72 times. The question comes that what is the probability of having a random experiment getting one head, two head and no head? So if I consider this event to be event 1, this event to be event 2 and this event to be event 3. Okay, so we are considering this event as event 1, this is event as event 2 and this event as event 3. Then we can say that probability of event 1 is going to be, how many times we have done the experiment? 400 times. How many times we got a 2 head? 180 times, right? So it's 9 by 20. 9 by 20, right? Now if I'm going with the second one, probability of event 2, then it is 148 by 400, right? 148 by 400. So 4 3s are 12, 28, 4 7s are 28 by 100. So it's 37 by 100. And probability of event 3, that is 0 head, we will be having 72 by 400. 72 by 400. So 72 by 400, if I simplify, 9 by 50, right? So we are getting 9 by 50, 37 by 100 and 9 by 20 as the probability of the events. Okay. So this is comparable to, if you wish to convert them into percentage, then this is 45%, this is 37% and this is 18%. Okay, so this is the way we can convert them into percentage. Okay, fine. So this is what our answers are for this question. Now let me go ahead with the Sumit Sukla's question. Sumit asked me a very interesting question. He says that why the probability cannot be more than 1. Okay, so for that I will be taking help of this formula. Okay, number of trials which in the event happen by total number of trials, uh, that happen. So let me consider this to be more than 1. Okay, as you said, I am considering this to be more than 1. So if it is more than 1, like say it is greater than 1, you are saying greater than 1, then what will happen? So if it is even more than 1, then if I cross multiply it here, okay, just consider it, this is called an inequation. So if I cross multiply, it will act as an equation. Okay. Hi Saraswati. So if I cross multiply, just think what is happening. I'm just trying to write it down. So number of trials in which the event happened is greater than total number of trials. So number of trials which is in which the event happened by is greater than total number of trials, right? So just think, you are throwing the coin. So what it means, if I just try to give an example, then what this mean is something which is quite impossible. Why? You are throwing a coin 600 times, okay, and you are getting heads 640 times, because it says number of trials which in the event happen by is greater than total number of trials. So total number of trials is 600 and you are getting head by throwing a coin more than 600 times. So it is something which is impossible, right? So we cannot have the probability of an event more than 1. Okay, it needs to be always in proper fraction. Clear? Hi Sunil Dutt, how are you? So next question is, a die is thrown 500 times. Its outcomes are noted as given below. So it says that its outcomes are given noted as given below. One we got 95 times, 2 I got 80 times, 3 84 times, 4 68 times, 6 70 times, and 6 130, 103 times. So a die is thrown at random. Find the probability of getting 1, 2, 3, 4, 5, 6. Okay, I'm considering them as event 1, event 2, event 3, event 4, event 5, as event 6. Okay. So what is the probability of event 1? The question is, what is the probability of event 1? So it will be 1, 1 we got 95 times, so 95 by 500, right? Probability of event 2 is going to be 80 by 500, because we got 80 times 2 when we thrown the coins 500 times. Probability of event 3 is going to be very simple, 84 by 500, right? Probability of event 4 is going to be 68 by 500. Probability of event 5 is going to be 70 by 500, and probability of event 6 is going to be 103 by 500. Okay, so these are the different ways we can predict the probability of every event. Okay, you have to simplify them to get the proper answer. I'm not going for the simplification here. So this is the way we can say this is this many times if you throw the coin, this is going to be the probability of the given events. Okay. Okay, Sumit is simplifying them. Yeah, that's good, Sumit. Let's try to simplify also. So if I cancel out by 5, then we have 100, and in the numerator we have 19. So this is something 19%. It is 100. 16. So this is 16%. Right? So it is 100, and if I simplify it by 5, if I cancel out by 5, then I get 5 ones are 5 6 are 5 8s are, so 16.8%. Third one, if I cancel out by 5, it is 100, and numerator will be 5 ones are 18, 5 3s are 15, 30, 5 6 are 30, so 13.6%. And then if I cancel out by 5, it's 100, 14, so that is 14% minus Hi Manas, how are you? Hi Varun. And here if I simplify by 500, I get 100 here. Here I get 20.6, right? So it is 20.6%. So this is what the answer is in percentage, but it is not required to always convert them in percentage. We can keep our answer in fraction form also. Okay, so we are going to start with this question now. On one page of the telephone directory, there were 20 telephone numbers. The frequency distribution of their unit digits are given in the following table. So this is the unit digits of the 200 telephone numbers and their frequency is given. The question is, what will be the probability of 6? I will be waiting for your answer. What will be the probability of getting a 6? So anyone with the answer? I'm just waiting for the answer. 6 we got 14 times, right? So the first one, if I consider that as event 1, then probability of event 1 will be 14 by 200 or 7%. Hello Anshu. Second one is a non-zero multiple of 3. A non-zero multiple of 3, right? So what will be a non-zero multiple of 3? A non-zero multiple of 3 will be 3, 6 and 9, right? So if I consider that as event 2, then probability of event 2 will be, the probability of event 2 will be 22 plus 14 plus 20 divided by 200, right? So 42, 52, 56 by 200, right? That is 28%. Non-zero multiple of 3, Shumit, so it will also include the 3, okay? That will also includes the 3. 3 itself the multiple of 3, right? 1 into 3. So 3, 6 and 9. Now non-zero even numbers. So that is 2, 4, 6 and 8. Non-zero even numbers. I consider this event to be event 3. So probability of event 3 is going to be 200 in the denominator. It's going to be 22 plus 20 plus 14 plus 16. So 14 and 16, 30, 30 and 20 is 50, 72 by 200, that is 36%. Okay, now we go with the fourth one. Here the event 4 I am taking. So probability of event 4 is going to be an odd number, right? So an odd number will be 1, 3, 5, 7 and 9, right? So 26, 3, 22, 5, 10, 7, 28, 9, 20. 200. Okay, so 28 and 20 is 50, 70, 80, 106, right? So it's 53% will be the answer, right? So this is the simplification. Okay, I don't believe there is any doubt. Okay, next question given. According to meteorological report of 300 consecutive days in a year, its weather forecasts were correct 180 times. Out of those days, one day is chosen at random. What is the probability the occurrence? What is the probability that the weather forecast was correct on that day and is not correct on that day? Okay. So the weather forecast will be correct on that date. If I consider that event as E1 and this event as E2, the probability of event E1 is going to be 180 times we got it correct by 300, right? So it gives me 6 3s are 6 5s, so 5 by 3. Sorry, 3 by 5. Okay, and not correct will be the event probability of event 2, right? Not correct will be probability of event 2. So probability of event 2 will be, if 180 times correct, then 120 times not correct, like 300 minus 180, right? So it is 120 by 300, 0 0 get cancelled, 2 by 5 is the answer. Okay, so 2 by 5 will be the answer for this question. Survey of 250 girls in a school was conducted, and it was found to be found that 150 girls like tea while 450 dislike it. Out of these, one girl is chosen. What is the probability that she likes the tea, she doesn't like the tea? Okay, so we are considering he likes the tea is event T1 and don't like the tea as event T2. So the first one, probability of event T1 is going to be the number of times number of students do like the tea, that is 105 divided by 250, right? 105 divided by 250, and that gives me the answer as if I cancel out by 5, then 50 in the denominator and 21 in the numerator. So this is, or 42% is the answer, and probability of event E2 is going to be 145 divided by 250. 145 divided by 250. So if I cancel out, I get 50 here. If I cancel out, I get 529 years. So 58% students don't like it, right? 58% students are there who don't like the tea at all. Clear? Chalo. In a sample survey, 465 people, it was found that 516 people have high school certificate. A person is chosen at random. What's the probability she will have a high school certificate? So tell me in the chat that which option will be correct. We consider having a high school certificate is considered to be the event E1. Okay, this is considered to be the event E1. So you guys need to tell me in the chat that what is the correct answer now. So probability of event E1 will be 516 divided by 645, right? So if cancel out by 3, we get 3 ones are 3 sevens are 3 twos are 3 twos are, right? Okay, Now if I cancel out, it will give me 4 by 5. They are divisible by 43. Okay, so option D is the correct answer. 4 by 5 is the correct answer. Okay, we'll go for the next question. In a medical examination, student in a class following blood group is being recorded. The blood group A is 11, B is 15, AB is 8, and O group is 6. What is the probability that if a person is chosen will have AB group? Okay, so total number of our students are not given, so that's what I have to first find out. 14 6 and 8 is 14, 14 and 15 is 29, and 11 is 40. So there are 40 total students. So probability of AB will be 8 by 40, right, or 1 by 5. So option C is the correct answer. Option C is the correct answer. We'll go for the next question. It's given 80 bulbs are selected at random uh, from a lot, and their lifetime in hours is recorded under. So what is the probability that a life will be 115 hours? A life will be 115 hours. So there is no thing that is it's given 115 hours. So the probability of this event is an impossible event. So its probability is going to be 0. Okay. So in the next question it says that in a survey of 364 children aged 19 to 36 months, is found to be 91 like to eat potato chips. If a child is selected at random, probability he don't like the potato chips. Okay, so if 91 people like to eat the potato chips, then we can say 364 minus 91 child don't like potato chips, so that gives me 3 and 27. So the answer is coming out to be probability of that event is 273 by 364, right? So 273 divided by 364 gives me 3 by 4 as the correct answer. Okay, so option C is the correct answer. Okay, so don't forget to go for the code ST18 for all such cases, all such type of sessions. Come on Unacademy. Try to go for plus subscription. For first instance you can go for 6 months. If you like you can extend it. Okay, so it will give you 10% of discount if you are using the ST18 code. Okay, so don't forget to use the code ST18 for 10% of discount. Let's crack it. This is our motto, and we are just going ahead with this with the help of you guys. So it's possible to crack from the home comfort, from your home. You just need to be a little bit serious and come on the Unacademy Plus platform. Okay, thank you for joining the class. Stay tuned for the next week. Next week also we'll be having some of the classes. Stay tuned, and don't forget to share the link of this video to with your students.